So this week we'll be doing separating a mixture of compounds. And as you might imagine, this is something that chemists have to do quite regularly. We get a mixture and we need to separate the mixture out. Click here on week 6. We have our module overview. Watch this is this video is replacing the video there now. And then we have our directions and our place where we're going to turn in our lab. So this gives you a little summary about what's in the mixture, and the procedure is going to guide you through how to separate it. Make sure that you record all the digits and use correct units. We studied significant figures in that first week so that we could use them the rest of the term, not so that you could use them that one week and then forget them the rest of the term. So the first thing you're going to want to do is download the lab outlet. I've downloaded it. It's right here. This should be fairly familiar format by now. You'll write your purpose, your background, a summary of the procedure. This means you have to read the procedure carefully and summarize it. A diagram works well with this kind of procedure, and that would be all right if you want to do a diagram. And then you'll put your data. Now, when you do the lab, we go back to here. When we do the lab, you'll come up here to, I'm looking for it, it's the very top, the new link to lab simulations. We click here, we go to Hayden McNeil, and this will look, okay, we've got it set up as a student. So we've got separating a mixture of compounds, and you click this little green book here. Okay, and you need to read this information. This is important information. If you were in a physical class, we would go over this information. So you're responsible for it, and you need to have read it and understood it. If you don't understand it, let me know. So these are methods of separating, techniques, and what physical property the separation is based on. So you'll use some of this information to do your background. When you finish here, you'll click here, and this will give you your lab procedure. This is what you're supposed to do step by step. Okay, so the first thing you'll do is take an evaporating dish and place it on the workbench, take a balance, and then we're going to mass the evaporating dish. You will put the mass of the empty evaporating dish here. Then you will add your powdered mixture. I believe you're supposed to add about 10 grams. And you'll put that right below. If you subtract off the mass of the empty dish from the mass of the dish and the powdered mixture, you'll get just the mass of the mixture that you started with. Okay? Now we need to, let's see, we're going to, okay, so for part 2 here, we're going to remove the aluminum chloride. So to remove the aluminum chloride, you're going to heat the evaporating dish. So after we heat it, we have burned off all the ammonium chloride. So we can put aluminum chloride. So you can put that number here after heating. To figure out the mass of the aluminum chloride that was removed, you subtract the mass of the evaporating dish and contents after heating, which is this number right here, from the mass of the evaporating dish and the powdered mix. So this is the mass of the evaporating dish and the powdered mix before heating. The difference in those two numbers will give you the mass that's missing. The missing mass is the ammonium chloride. We then want to calculate the percent of ammonium chloride in the sample, and we'll do that by taking the mass of the ammonium chloride, which is the number that will be in this box, and dividing it by the mass of the powdered mixture, which is up here where you calculated the mass of the powdered mixture. Just make sure you're getting the right numbers. Take that and multiply by 100, and you'll get the percentage of ammonium chloride. Then we have the mass of the empty sand beaker and the mass of the beaker with the sand after decanting. This is after you poured off all the water. The difference in those two numbers will be the mass of the sand. We take the mass of the sand and divide it by the mass of the powdered mixture from all the way up here. We'll get the percentage of sand in our mixture. The last thing is to find the percentage of salt. So we take the mass of the empty beaker, this is the beaker that's going to have the salt in it, and the mass of the beaker after the water's been boiled away. Well, after the water's been boiled away, the only thing left in that beaker is salt. So if we subtract off the mass of the beaker, we'll have the mass of the salt. So these two numbers, the mass of the empty beaker and the mass of the beaker with the salt, will give us the the mass of the salt. And then we can calculate the percentage. The mass of salt divided by the mass of the powdered mixture times 100% will give us the percentage of salt. Now, if you've done this correctly, your three percentages will add up to 100 or very close to 100. You might get 99.99 or something, but it should be very close to 100. Now, Part 5 sometimes throws people, because what I've done here is I've said, well, I'm going to give you a different accepted or true mass percent of so the true mass percent is 6, not whatever you got. And so you'll put that into this formula here. You take the accepted value, which in the case of the ammonium chloride is 6, minus your calculated value, and then divide by the accepted value, and you'll get the percent times 100%, and you'll get your percent error. Put that right here. And you could do the same thing with the sand and with the salt. And then I want a well-written conclusion. Did you look back at the purpose of the lab? Did you accomplish the goals in your purpose? And restate your percentages, comparing them to the true value. Which values were more accurate? One thing, when people read scientific papers frequently, they will skip to the back and just read the conclusion and then decide whether they want to read the whole paper or not. So this complete paragraph should summarize all your results so that you'll have complete information for your reader. Okay, so that is it, and good luck with this lab. Let me know if you have any trouble with it, and I'm here.